Hello! In this video we will walk through a logic problem that involves deductive reasoning. The goal is to determine which statements must be true based on a set of conditional premises. By the end of this walkthrough you will be able to first convert statements from English into formal logical expressions, and second use deductive reasoning to determine all possible outcomes based on these expressions. Here's the problem. 5 colleagues, Anna, Ben, Clara, David and Elena are deciding whether to attend a company retreat. They each make a statement about their attendance. We are told that the statements made by Anna, Ben, Clara, David and Elena are all true. Our task is to determine which of the given statements are also guaranteed to be true. The statements are: Anna says she will go if and only if Clara doesn't. Ben says if Anna goes, he will go. Clara says if David goes, she will go. David says either he or Elena will go, but not both. And finally, Elena says if Ben doesn't go, she won't go either. The key to solving this type of problem is to break it down. First, we will convert each English statement into a precise logical expression. This will create our set of rules, our premises. Let's get started. Our first step is to translate these English sentences into the language of logic. This is a crucial step because it removes any ambiguity. We'll start by defining a simple variable for each person's attendance. Let's use A for Anna attends, B for Ben attends, C for Clara attends, and so on. We can also use not A to mean Anna does not attend. Let's translate the first statement. Anna says, I will attend if and only if Clara does not attend. The phrase if and only if is represented by a double-headed arrow. So our first logical premise is A, if and only if not C. This means Anna and Clara will always have opposite attendance statutes. Next is Ben's statement. If Anna attends, then I will attend too. The phrase if then is a conditional statement represented by a single-headed arrow. So, if Anna attends, Ben must attend. This is our second premise. Clara's statement is similar. If David attends, I will attend too. Again, an if-then structure. Our third premise is D implies C. This means if David attends, Clara must attend. David's statement is a bit different. Either Elena or I will attend, but not both of us. This is a classic definition of an exclusive or, often denoted by a circle plus symbol. This premise tells us that the attendance of David and Elena must always be opposites. This is a very strong constraint. Finally, Elena says, if Ben does not attend, then I will not attend either. Let's translate this part by part. This gives us our fifth premise. Not B implies not E. An important logical tool here is the contrapositive. The statement not B implies not E is logically equivalent as E implies B. That is, if Elena attends, Ben must attend. We will find this form easier to work with. So, we have successfully completed our first objective. We have our 5 premises written in the precise language of logic. Now we can proceed to the second step, finding all scenarios that satisfy these premises. Our next task is to find all the possible scenarios or assignments of true and false to our variables A through E that satisfy all 5 of our premises simultaneously. Remember, our goal is to find all such scenarios as we will need them to test the final statements. The total number of possibilities is 32, since each of the 5 people can either attend or not attend. Testing all of them individually would be tedious. Instead, we will use casework. We will pick a variable with a strong constraint and consider its 2 possibilities. Let's choose Anna attends. Variable A. Why Anna? Her first premise, A if and only if not C, is a very powerful one that immediately determines Clara's attendance once we know Anna's. So we will analyze 2 main cases. Let's begin with our first main case. Case 1. Let's assume Anna attends. In our logical notation, this means A is true. From premise 1, which states A if and only if not C, we know Anna and Clara must have opposite attendance. So, if A is true, then C must be true. This means Clara does not attend. Now let's use premise 2, A implies B. Since we know A is true, it follows that B must be true. So Ben attends. Let's turn to premise 3. D implies C. We already determined that C is false. For a conditional statement like D implies C to be true, if the conclusion C is false, the premise D must also be false. Therefore, David does not attend. Now we use premise 4, D exclusive or E. We have just found that D is false. For this exclusive or to be true, E must be the opposite of true, so Elena attends. We have one last premise to check, premise 5, which in its simpler form is E implies B. We found E is true and B is true. The statement true implies true is true, of course. So this premise is satisfied. We have found our first complete, consistent scenario. When Anna attends, Ben attends, Clara doesn't, David doesn't, and Elena attends. This means 3 people attend in this scenario. Now let's examine our second main case, which is itself divided into 2 subcases. Case 2. Let's assume Anna does not attend. In our logical notation, this means A is false. Just as before, we start with premise 1, A if and only if not C. If A is false, then C must also be false. This means C is true. So Clara attends. With A being false, let's look at premise 2. A implies B. A statement like false implies B is always true, regardless of whether B is true or false. This means Ben's attendance is not determined by Anna's non-attendance. Ben could attend or not. This is why we have 2 subcases. Case 2. Let's assume David attends. So D is true. From premise 4, D exclusive or E, since D is true, E must be false. Elena does not attend. Now we need to consider premise 5. E implies B. Since we found E is false, the statement false implies B is true regardless of B. So Ben's attendance is still not determined by this information. We have to split this subcase again, giving us 2 more scenarios. If we choose to be true, we get scenario 2. Anna doesn't, Ben does, Clara does, David does, and Elena does not. 3 people attend. If we choose B to be false, we get scenario 4. Anna doesn't, Ben doesn't, Clara does, David does, and Elena doesn't. Only 2 people attend in this case. We're not quite done with case 2. Remember, Ben's attendance was undetermined after we established A is false and C is true, or subcase 2A. Assume D is true. What if D is false? This gives us subcase 2B. Subcase 2B. Let's assume David does not attend. So D is false. From premise 4. D exclusive or E. Since D is false, E must be true. The opposite. So Elena attends. Now we use premise 5. E implies B. Since E is true, B must also be true. Ben attends. This gives us our 4th and final consistent scenario. Anna doesn't, Ben does, Clara does, David doesn't, and Elena does. 3 people attend. So, we have successfully enumerated all 4 possible ways the colleague's attendance can play out. We have completed the most crucial part of this problem. Let's put them all in a table for clarity. Notice that in 3 of the scenarios, exactly 3 people attend. In one scenario, only 2 attend. Now that we have our complete set of valid scenarios, we can finally evaluate the 5 statements given in the problem. A statement is correct or must be true if and only if it holds in all 4 of our valid scenarios. If we find even one scenario where it's false, the statement is incorrect. Let's start with statement A. If David attends, then Anna does not attend. In logic, this is D implies not A. We need to check every row in our table. Let's check the scenarios. In scenario 1, D is false, so D implies not A is true. In scenario 2 and 4, D is true, and in both cases, A is false. True implies true is true. In scenario 3, D is false, so again, the implication is true. Remember the truth table. Since D implies not A holds in every scenario, it must be true. So statement A is correct. Next statement. If Ben attends, then Anna attends. In logic, this is B implies A. We're looking for any scenario where Ben attends, but Anna does not. Let's check scenario 2. Here, Ben attends, B is T. But Anna does not attend, A is false. The statement if true, then false is false. So we have found a counterexample. Statement B is incorrect. Statement B is incorrect. Statement B is incorrect because it's false in at least one scenario. It's not necessarily true. Let's look at statement C. If Elena attends, then Anna attends, or Clara attends. In logic, this is E implies the disjunction of A and C. We need to check that whenever E is true, at least one of A or C is true as well. Let's check the scenarios where Elena attends, which are scenarios 1 and 3. In both scenarios where Elena attends, the condition A or C is met. Therefore, statement C must be true. For statement D, at most 3 of them attend. This means the number of attendees can be 0, 1, 2 or 3, but not 4 or 5. Let's look at the attending column in our summary table. For scenarios 1, 2, 3, 3 people attend. For scenario 4, 2 people attend. In all 4 valid scenarios, the number of attendees is 3 or less. Therefore, statement D must be true. Statement D is correct. Finally, statement E. If Anna does not attend, then David attends. In logic, this is not A implies D. We need to see if Anna's absence always guarantees David's attendance. Let's find a scenario where Anna does not attend. A is false and David also does not attend. D is false. That would make the statement false. Let's look at statement 3. In scenario 3, Anna does not attend, but David also does not attend. So not A implies D is false. Statement E is incorrect. Let's quickly recap our findings. We started by translating 5 English statements into a precise set of logic premises. This eliminated any ambiguity. Then, through careful casework on the first premise, we deducted all 4 possible consistent attendance scenarios. Finally, we evaluated each of the 5 proposed statements by checking if it held true in every single one of our valid scenarios. Our analysis showed that statements A, C and D are correct and must be true, while statements B and E are incorrect because we found at least one scenario in which they were false. So we have achieved our learning objectives for this video.